Hey guys, let's do some proofs. Woo! You might be wondering, what's with the red hat? Well, let me put it to you in proof language. So I'm going to give you a conditional. If Mr. Lowry doesn't do his hair, then Mr. Lowry will wear a hat. Mr. Lowry didn't do his hair today, therefore Mr. Lowry is wearing a hat. That's a great example of the law of detachment. So, a little proof intro for you. Today we're going to be talking about properties of equality and congruence again. And I know you might be thinking, like, we've already talked about these a few times, and that's true. The tricky part is that the symbols that we use are a little bit different for segments versus angles. And so we want to go through these properties again because we want to be able to talk about angle measurements and angle congruence and kind of compare those. So just like we had kind of in the last lesson, I have two sections here, properties of equality and properties of congruence. And we're going to run through kind of more quickly this time those different properties. And your homework for this lesson, you're going to actually prove these. Now, if you're like kind of scared about that, the proofs for these properties here are basically identical to the ones we did with segments. You just have to translate them to angle measurements instead of segments. So the reasoning, the logic behind that is the same. You don't have to come up with that on your own. You're just going to kind of copy over from what we did earlier. You're just going to put it in angle language instead of segment language. But I will get you started and go through one of these proofs with you. Before we do that, though, let's just talk about the properties real quick one more time and just put it in angle language, okay? So recall the reflexive property of equality. Things are always equal to themselves, right? Pretty common notion, pretty obvious. So what we have here is like 5 is always equal to 5, right? X is always equal to X. But if we want to put it in angle language, what we say is the measure of angle A is always equal to the measure of angle A. There's a postulate that we had a chapter or so back that was called the protractor postulate. And the protractor postulate says that any angle can be measured and given a degree measurement, right? Every angle has some real number measurement behind it. So if we're talking about the measurement of an angle, we're talking about just a plain old number, right? So when I say measure of angle A, we know that that's some number between like 0 and 180, basically. So this is still the same thing. It's just saying that some number is equal to itself, okay? So when we're talking about equality, we need to have that little m in front of it, which is talking about measures. Because angles can't be equal to each other. Angles can be congruent to each other. The measures of angles can be equal to each other, but an angle is a shape. So it doesn't make sense to say a square is equal to a square. You could say the perimeter of this square is equal to the perimeter of this square, or you could say that two squares are congruent or something like that. But you can't say two squares are equal. Okay, and the same thing is true for angles. So notice over here on the reflexive side of when we're talking about congruence, we can say angle A is congruent to angle A. Over here, we're saying the measurement of angle A is equal to the measurement of angle A. So if you have those m's there, talking about a measurement, a number, we use an equal sign. When we don't have an m out in front, we're talking about an angle, a shape, we use a congruent sign. Okay, so any angle is congruent to itself. Okay, we're actually going to prove this in just a second. This is pretty common notion. If we just take our properties of equality and we add to that the definition of angle congruence, we can get this pretty easily. Okay, let's go through symmetric real quick. Okay, symmetric is when you can switch the order of things that are around an equal sign. So if you have an equal statement, x equals 3, you can change the 3 and the x. 3 is equal to x, it's still the same thing, okay? In angle language, though, if you have the measurement of an angle equal to the measurement of an angle, remember, these are just numbers. So we can switch those two, we can switch the order and say that measure of angle B is equal to measure of angle A. So again, we have m's. We're talking equality, we're talking numbers here, okay? Over on this side, this is the symmetric property of congruence. So if angle A is congruent to angle B, then I can switch them and say, okay, well, angle B is congruent to angle A. So it goes both ways. Now, again, we're going to have to prove this in today's lesson, but this is the difference between equality and congruence, right? Notice there's no m's here. We're not talking about measurements. We're not talking about numbers. We're talking about a shape, an angle being congruent to another angle, a shape being congruent to a shape. Okay, and then our transitive property, of course, we have basically two statements and then we chain them together, right? So if 3 equals x and x equals y, well then 3 has to equal y, right? We jump over that middle piece. And this is also very similar to the law of syllogism if we have if-then statements, right? So this is kind of an if-then statement, right? So if this, then, and this, then this. That's kind of what's going on here. So we had, for the law of syllogism, it would be like P implies Q, Q implies R, therefore P implies R. So transitive property, very similar to the law of syllogism. Okay, now if we're talking angle measurements, if we have a measure of angle 1 equal to a measure of angle 2, so the measurement of a first angle is equal to the measurement of a second angle, and then the measurement of that second angle is equal to the measure of a third angle, we know the first angle and the third angle, the measurements have to be equal as well. So notice, all equal signs, we have m's in front of all the angles because we're talking about the measurement. We're talking about a number. Over here, this is the transitive property of congruence. Now we're talking about shapes, right? So if one angle, one shape is congruent to a second angle, and that second angle is congruent to a third angle, then the first angle has to be congruent to a third angle. You're going to prove this here, but again, the reasoning is very, very similar to what we do with segment proofs. All you got to really do is invoke the definition of congruence, use the property of equality, and you're pretty much there. So let's go through the first one here. I'll get you started, and you can see how these are going to mirror the proofs that we did in the last assignment here. So first up, we got we're actually proving the reflexive property of congruence here. We want to show that any angle is congruent to itself. So we start with just a plain old angle, angle A, and we're going to prove that it's congruent to itself. All right, so we start with an angle A, given. No big deal. Okay. Now this one again is kind of the tricky one, just like it was with segments, because we kind of have to call upon something we don't use very often, and that is the protractor postulate. And that again is the idea that says if we have an angle, it's going to have some real number measurement that goes with it, right? It matches to some measurement. So we're going to say angle A has a real number measurement, and we call that measurement the measure of angle A, right? And we can say that because a chapter ago or so, we had something called the protractor postulate, which says you can match up any angle with a real number. Okay, so this is going to be the protractor postulate. Now, when we did this proof with segments and segment congruence, we said it was the ruler postulate. Our justification was the ruler postulate. This time it's the protractor postulate. Okay, next, now that we're in measurement, we can say something like this. The measure of angle A is equal to the measurement of angle A. Right? That is a reflexive property, but it's the reflexive property of equality, which we can kind of assume that we have. It's a common notion. So we can assume that this is just a number. It's got to be congruent to itself, right? Reflexive property of equality. So I'm going to go reflexive prop of equality. Okay? All we got to do now is we got to just change this back to congruence, and we do that by using the definition of angle congruence. The definition of angle congruence is just that if two angles have the same measurement, they're congruent. Okay, so we can say that angle A must be congruent to angle A because they have the same angle measure. Definition of angle congruence. We're going to write def of cong. Okay, so it's, congruence pretty much means the same thing whether you're talking about an angle or a segment. It means the measurement is the same. So, definition of congruence. Now that should look very familiar to you because it's pretty much identical to when we did this proof for segments. We wanted to prove that each segment was congruent to itself, and we did that in our last lesson. So this is very, very similar. Now what you're going to do is you're going to prove, in your homework, you're going to prove this guy, and you're going to prove this guy. Okay? And the technique, the strategy you're going to use is similar to this. You're going to start with, the given. You're going to use, you're going to switch to equality basically by using the definition of congruence. You're going to use a property of equality, and then you're going to switch back to congruence. So that's kind of the template. If you get stuck on these in your homework, go back and watch the videos where I proved these for segments and just copy them, but change it to angle measurements and angles and angle congruence, and you got it. Okay? Thanks.